do a lesson on day 2 here. So we're going to solve radicals again, similar to what you did yesterday. But the biggest thing we're going to do here is we're going to use some quadratics, okay? So we need to remember the fast way to square a binomial. So remember, you square the first term, you square the last term, and then people tend to leave this guy out. You multiply them together and double it. And if you don't believe me, then expand this sucker out, and you'll see that 2 of those ABs show up in the middle. So this guy is going to be x squared. Multiply them together and double it, and square this guy over here. Over here, watch out for that negative. Square the first time. When I multiply them together and double it, I'm going to get a minus 16x. And when I square that last one, I'm going to get a plus 64. Same thing works when we have these multiples down here. 9y squared. Multiply them together. 6yz, double it. 12yz. And then square the last term. 4z squared. And we're in good shape. We're going to be squaring some binomials a little bit today, so we'll go from there. Very important that you understand this is directly from yesterday, and the biggest thing today is step 4. You're going to have to check your equation, because when I square this, we talked yesterday about how you're not allowed to take the square root of a negative, so we need to plug back in. Otherwise, you might have some extraneous roots. What are the first 5 letters of the words extraneous? Extra, extra. Got to be careful. Again, isolate the radical on one side, and then you're going to square both sides. If it was a cube root, you'd cube and things like that. So here we go. Let's get to it. This one's already set up. Square both sides. 30 minus x. What happens when you square a square root? It gets set free. Set me free is equal to x squared. I like to have my lead term be positive. I'm going to slide this guy over here. I'm going to slide this guy over here. 0 equals x squared. I added that x over, and I subtract that 30. And here we are again. Your old friend factoring. We'll be doing this all year long. What a great deal. And I'm going to split up the x's. What do I multiply for negative 30? Add for positive 1. It's going to be a positive 6 and a negative 5. So factoring just never goes out of style. X plus 6 is equal to 0. Add 6. X is negative 6. X minus 5 equals 0. Add 5. X is 5. Got to go back to the original problem, okay? I got to erase a couple things here, otherwise it gets to be a little confusing. I had shown my work there. Now, when I head up here to check my work, 30 minus negative 6. Well, 30 minus negative 6 is the square root of 36, which is positive 6. But as I plug that sucker in there, I would get 6 is equal to negative 6. That's extraneous. Just put a little x through it, we're fine. 5 up in there, 30 minus 5, 25. Square root is positive 5. We are good. Extraneous, and that one's good. The answer here is 5. You need to isolate the radical first. Add the 2 to the other side. Plus 2, plus 2. Show my work like a good little soldier. Square root of x plus 14 is equal to x plus 2. Here we go. Why did we spend that time squaring that binomial on that first page? Well, here's why. Because now I got to square both sides. Once you get the square root by itself, you're allowed to square both sides and set it free. It's been set free. X plus 14. Got to remember how to square a binomial. If you're not comfortable squaring it the fast way, then, x plus 2 times x plus 2. That's fine. X squared, multiply them together and double it, and square the second term. I would minus the x over, and I would minus the 14 over, and now I get 0 equals x squared plus 3x minus 10. Now I'm going to factor. Factoring. When am I ever going to use this in my life? Duh. Solving radical equations. Holy cow. And then I think to myself, what do I multiply together to get negative 10 and add together to get positive 3? It's got to be positive 5, and it's got to be negative 2. Set them both equal to 0 and solve. X plus 5 equals 0. X is negative 5. X minus 2 equals 0. X is 2, check your work. Negative 5 up in here. That's negative 5 plus 14. That's the square root of 9 minus 2 is equal to negative 5. Is 3 minus 2 equal to negative 5? No, you silly goose. That's extraneous. Put a 2 up in there. 2 plus 14, square root of 16 is 4. Is 4 minus 2 equal to 2? Yep, last time I checked, we are in good shape. Let's try another one. Again, we're looking for isolate the radical. Radical, both of these are by themselves, kind of boring little problems. That's okay. Square both sides. X squared minus 6x plus 9 equals 30 minus 2x. And now I'm going to bring both of these guys over. X squared minus 4x minus 21 equals 0. And we go with this guy, x minus 7, x plus 3. Set them both equal to 0 and solve. I get 7. I get negative 3. Go back up there. 7 minus 3. That's 4. Is 4 equal to the square root of 30 minus 14? 30 minus 2 times 7 is 4. Yep, we're good. That one's going to work. Now, you do have to check. I got to put a negative 3 minus 3. That's negative 6. Is it possible for me to have a positive square root equal to a negative number? It is not. And you could put this in there. I'd get the square root of 30 plus 6, which is the square root of 36. But that is not going to be the case. That is extraneous. All right. Here we go again. Let's see if we can handle this one. I'm going to square both sides. Why don't you do that right now? And I'll catch up with you. And we go and we square both sides. And we square both sides. And we get 4x plus 13 equals x squared. Multiply them together and double it. And square the next one. Good. Slide it over, slide it over. 0 equals x squared. Whoa, 4x minus 4x, that's 0x. Do I write 0x? No, only if you want people to point and laugh. 4 minus 13 minus 9. How do I deal with that? Oh, no. Oh, no. Oh, yeah. The difference of two squares coming through again. X plus 3, x minus 3. Equals 0. Set them both equal to 0. I get positive 3 and I get negative 3. I'm not going to go with a plus or minus on this one because I got to check my work. I put a 3 up there. I get 12 plus 13. That's the square root of 25 equal to 5. Yep, we're good. The negative is going to be a problem, though. Negative 12 plus 13 is 1. Is the square root of 1 equal to negative 1? It is not. That is extraneous. You just can't do it, sir. You just can't do it. Sometimes I get people who look at this problem and they think, hey, we can't do that one because the square root isn't equal to a negative. But look, that's a variable. So we can make it swing at this one. Let's go. 5y plus 6 equals y squared. Slide it. Slide it. Why do I go that way? I always like to have my lead term be positive because that makes things easier. And now I say, hey, what do I multiply together to get negative 6 and add together to get negative 5? It's got to be negative 6 and positive 1. How many of you are thinking 2 and 3? Oh, you silly gooses. 2 and 3, if I would have had to be both be negative, then I would have a positive 6 over there. If they were both positive, I'd have a net positive 5 in the middle. Don't work. Set them both equal to 0 and solve. Y minus 6 equals 0. Y is 6. Y plus 1 equals 0. Y is negative 1. But look at this. Look at this. I put the 6 up there. I get the square root of 36, which is 6. Is that equal to, look at, the original problem is negative 6. You just can't do it, sir. Extraneous. Negative 1, I put that up in there. I get the square root of negative 5 plus 6. That's 1. Is that equal to negative 1? We won? Yeah. So even though we had to change that sign, and we're okay. All right. You got some homework to work on? Go get them.